Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and if you're enjoying our show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you.
And I'm Victor. Today we're wrapping up Chapter 2 of Season 2, where we've been exploring Hyperswarm networking. This chapter summary will tie everything together and reinforce what we've learned about this crucial component of the Holepunch ecosystem.
Before we dive in, let's start with a quiz question for our listeners. What unique feature of Hyperswarm allows peers to efficiently find each other without relying on centralized servers?
That's an intriguing question, Sheila. It really gets to the heart of what makes Hyperswarm special. Listeners, think about how traditional networking differs from peer-to-peer systems, and what might be needed to bridge that gap. We'll reveal the answer at the end of the episode, so stay tuned.
Great! Now, let's start our summary. Victor, could you give us a quick overview of what Hyperswarm is and why it's important in the context of decentralized applications?
Certainly, Sheila. Hyperswarm is a peer-to-peer networking stack that forms the backbone of the Holepunch ecosystem. It's designed to solve one of the biggest challenges in P2P systems: how to efficiently discover and connect peers without relying on centralized servers. This is crucial for building truly decentralized applications that can operate without a single point of failure.
That makes sense. So, if I understand correctly, Hyperswarm is like the social network of the P2P world, helping peers find and connect with each other. Is that a fair analogy?
That's a great analogy, Sheila. Just like how a social network helps you find and connect with friends, Hyperswarm helps peers find and connect with each other. But instead of using a centralized server to store all the connection information, Hyperswarm uses a distributed hash table, or DHT, to spread this information across the network.
Interesting. Can you explain a bit more about how this DHT works in Hyperswarm?
Of course, the DHT in Hyperswarm is a distributed system where each peer stores a portion of the network's peer discovery information. When a peer wants to join the network or find other peers, it queries the DHT. This query is routed through the network until it reaches the peers responsible for storing the relevant information.
That sounds efficient. But how does Hyperswarm ensure that peers can find each other quickly in such a distributed system?
Great question. Hyperswarm uses a concept called topic-based networking. Essentially, peers announce their presence under specific topics, which are like interest groups. When a peer wants to connect with others interested in the same topic, it can quickly find them by querying the DHT for that specific topic.
I see. So it's not just about finding any peer, but finding the right peers for your specific application or need. That's clever. Now, once peers have found each other, how does Hyperswarm handle connection management?
Hyperswarm takes care of establishing and maintaining connections between peers. It handles the complexities of NAT traversal, which is the process of connecting devices behind firewalls or routers. It also manages the lifecycle of connections, handling both the initial handshake and graceful disconnections.
That sounds like it takes a lot of work off the shoulders of developers. Are there any common pitfalls or misunderstandings about Hyperswarm that our listeners should be aware of?
Absolutely. One common misconception is that Hyperswarm guarantees instant connections between all peers. In reality, while it's very efficient, connection times can vary depending on network conditions and the number of hops required in the DHT. Another pitfall is not properly handling connection errors or disconnections, which can lead to unstable applications.
Those are important points to keep in mind. Do you have any best practices or tips for working with Hyperswarm?
Certainly. First, always design your application to be resilient to network partitions and peer churn. Second, use appropriate timeout values when establishing connections to balance between quick connections and allowing enough time for NAT traversal. Lastly, leverage Hyperswarm's topic-based networking effectively by choosing meaningful topics that align with your application's needs.
That's really helpful, Victor. Now, before we wrap up, could you share a real-world implementation example of Hyperswarm?
Sure. One interesting example is Keat, a peer-to-peer video chat application built on the Holepunch stack. It uses Hyperswarm to discover and connect users directly, allowing for secure serverless video calls. This demonstrates how Hyperswarm can be used to build privacy-focused, decentralized alternatives to traditional centralized services.
That's fascinating. It really shows the potential of this technology. Now, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Gladly. The unique feature of Hyperswarm that allows peers to efficiently find each other without relying on centralized servers is its use of a distributed hash table, DHT, combined with topic-based networking. This allows peers to announce and discover each other based on shared interests or application needs, all in a decentralized manner.
Thanks, Victor. To summarize the key points of this chapter, 1. Hyperswarm is a peer-to-peer networking stack that enables efficient peer discovery and connection without centralized servers. Point 2. It uses a distributed hash table, DHT, for peer discovery. Point 3. Topic-based networking allows peers to find others with shared interests quickly. Point 4. Hyperswarm handles complex tasks like NAT traversal and connection lifecycle management. Point 5. When using Hyperswarm, it's important to design for network resilience and use appropriate timeout values. Victor, any final thoughts on Hyperswarm?
Just that Hyperswarm is a powerful tool that solves many of the hard problems in P2P networking. Understanding and leveraging its capabilities can really elevate your decentralized applications. It's exciting to see how it's enabling a new generation of serverless, privacy-focused apps.
Absolutely. And that wraps up our chapter on Hyperswarm networking. We hope you found this summary helpful. If you did, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create more content like this. Until next time, happy coding.